New societal trends can significantly impact the energy demand. This is not only shown by the example of digitalization. However, there are also other trends, and the Horizon 2020 project New Trends aims to improve the modeling of these trends to support European decision makers. We do this in 4 focus studies: the circular economy for industry decarbonization, the digitalization in the tertiary sector, prosumerging in the built environment, and shared economy for the transport sector. In this video, I, Thurid Lotz from the Fraunhofer ISI, want to give some insights on our focus study on circular economy for industry decarbonization and answer some questions about the building value chain. So let's start with the basics. Why is circular economy actually relevant for industry decarbonization? So in the industry sector, we on the one hand really have hard to abate emissions and high costs for the expansion of the renewable energies and the grid. On the other hand, circular economy can really contribute to reducing the prospective material demand. Other focus studies or other studies have shown that circular economy has a huge potential, especially in the building sector, because it's one of the main demanders of steel and cement demand, which are especially emission-intensive basic materials. So how did we improve the modeling situation for circular economy along the building value chain? Firstly, we developed a stock-driven material flow analysis, as we identified this to be the most fitting approach for prospective scenarios of circular economy based on a literature review. The approach consists of 3 modeling levels. The first level showing the building in and outflows, the second level considering the steel and cement flows, and the third level for calculating energy demand and greenhouse gas emissions. However, such modeling approaches are no novelty. Our modeling approach improves the modeling situation by directly linking existing energy system models. We have on the one hand the building stock model Invert EE Lab, and on the other hand the bottom-up energy demand model of the industry Forecast Industry. In addition, we also develop building archetypes for the building material use in EU buildings by addressing different regions and building types. This type of archetype was until now not available for non-residential buildings, so we also improved the data situation and not only the modeling situation. So now the question is how we included circular economy in this model. We started out with a literature review to identify a comprehensive set of circular economy measures that we wanted to model. For this we used the 9R framework to have a good coverage of the different types of circularity measures. We then decided which kind of modeling mechanisms we wanted to use to implement these measures and figured out that we needed mainly 4 mechanisms to show the impact of the different measures. The first one is changing the building stock development provided by Invert EE Lab. The second one is changing process-related input factors like efficiencies or process shares. The third one are the building archetypes that can be varied in prospective scenarios to consider, for example, modern construction. And the last one is to introduce new flows into the material flow model for reuse or recycling of specific materials. And now, of course, the crucial questions. What do these results show? Firstly, we calculated a reference development showing the material demand for buildings up until 2050. We can see that the building demand or the demand for materials for buildings is increasing because the building stock is increasing. So we really need the circularity measures to bring this material demand down. Afterwards, we then calculated different circularity cases where we always looked at one measure at a time to assess the impact and compare the measures. In these graphs, the results are shown. On the first graph, we have the material demand reduction in megatons, and the second graph, the energy demand reduction in petajoule, and in the final third graph, the emission reduction in megaton CO2 equivalent. We can see all the 8 measures that we assessed, and we can also see the measures with the greatest impact. And this is the reduced overspecification of steel and concrete elements and the renovation of buildings. The measures with the lowest impact are the reuse of steel and the cement recycling. So overall, we can conclude that the circularity can have a huge impact on industry decarbonization and contribute in industry decarbonization scenarios. So now the question is, of course, what do we want to do with the model and with the developed approach in future? With the developed approach, we can actually look at different challenges related to circularity. We can, for example, consider the scrap availability, but we can also include further circularity measures that have not yet been covered by the model. We could also include further materials, as for example wood or insulation material, as they are commonly discussed in context of building decarbonization. And finally, we could also look at other scenarios, because we now only looked at a reference scenario without extra decarbonization effort. We could have different building stock developments, but also industry decarbonization scenarios that would impact energy demand and emission of the different measures. So if you're interested in that kind of studies, stay connected with the New Trends project, and thanks for watching.